In lesson 5.2, we're talking about oblique triangles, which are triangles that do not have a right angle in them. So we still want to be able to solve all kinds of triangles, not just the right triangles that we've been talking about all semester. So now we're going to use a new theorem called the law of cosines. If you want to pause the video and write down these theorems, you can, but I'm just going to talk through them real quick. So whenever I am labeling my triangle, my angles are going to be capital letters, and the sides opposite of them are going to be lowercase letters. So side little a is opposite of angle big A, side little b is opposite of angle big B, and then side little lowercase c is opposite of uppercase C angle. Now, if I want, so let's say I want to find side A, this is the formula I would use. It's much like Pythagorean theorem, where you have a squared equals b squared plus c squared, but since it's not a right triangle, you can't just stop there. You now have to do minus 2 times side b times side c times the cosine of angle A. So if you're looking for side A, you'll need angle A in order to do it. And it's law of cosines because it requires a cosine in all of them. If I'm looking for side B, it has angle B, side C has angle C, that's a C. And then so like if you're looking for side B, it's all A's and C's except for angle B. If you're looking for side C, it's all A's and B's except for angle C. Then all I did was I took these three and solved for cosine A. So I subtracted b squared and c squared to the other side and divided by negative 2bc. And that is how you get cosine A equals. So this is just a different version of the three that you see there. This would be when I'm looking to find an angle measurement. So if I want to know angle A, I would use this one. I would plug in all my sides for this and then do inverse cosine to the other side to find angle A. So these are your different theorems. And now we're going to use those in the next few examples. So in example 1, let's draw the triangle ABC that they are referring to. I always recommend drawing the triangle. So I've got angle ABC, little b is 5, so that's opposite of angle B. Little c is 7, so that's opposite of angle C. Capital A is 39, that's the angle, 39 degrees. And they want us to find side A. So we're going to use this first one where it says A squared. So let's write down the theorem. Okay, then fill in your important information. So I'm looking for A, I don't know that. B is 5. Side C is 7. B is 5, side C is 7. Cosine of angle A, which is 39 degrees. So we need to make sure that our calculator is in degree mode. So I'm going to type this in, make sure I'm in degree mode, which I am. And then it'll be 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 39. And I get 19.6 if you round. And then we want A, not A squared, so we take the square root of both sides. So square root of that. Hold on. Square root of 19.6 is 4.4. And that's what they want in example 1. Okay, example 2 is much like that, only they're using different letters, so it may be a little confusing on which law of cosines formula you want to use. All right, so angle S is 127 and 42 minutes, 127 degrees, 42 minutes. Where I'm going to put that for angle S. Side K is 15.78. Side D, which is opposite of angle D, 2.654. They want us to find side S. So if I want side S, let's use these letters to make the equation. It would be S squared equals K squared plus side D squared minus 2 side K side D cosine of angle S. And we happen to know all of those things. Where am I getting this from? I'm just changing all the A's, B's, and C's into K, S, and D. So if A is the one I'm looking for, and it's called S, then I changed those to S's. And if K and D are the ones I know, then I changed all my B's and C's into K's and D's. Because they all have that same pattern, just the letters change. So then if you fill in what you know, let's see, K is 15.78. D is 2.654. I'm running out of room. Cosine of 127, but I don't want minutes, so I'm going to take 42 divided by 60 to change that into a decimal of a degree, so 0.7 degrees. And now I'm going to type all of that into my calculator. We're in degree mode. Okay, 15.78 squared plus 2.654 squared minus 2 times 15.78 times 2.654 times the cosine of 127.7, which is 307.3. And we now need to take the square root of that. Which is 17.5. Okay, another thing to look out for is look at your answer and see if it makes sense, because there's ways you could be doing this wrong. 127 is an obtuse angle, so S has to be my largest side of the triangle. And 17 is larger than 15 and 2. It's also comparable to 15 and 2. If I got 1007, I would feel like something's wrong. Or even if I got this 307, that does not look right compared to 2 and 15. So maybe I forgot to take the square root. That should clue you in that you did something wrong, or there's still another step. Same thing up here. I got 4, which is very comparable to 5 and 7. So that, to me, seems right. Okay, example 3. They're changing the letters again. So let's draw this triangle. And let's label the sides. Opposite of x is 3. Opposite of y is 7. Opposite of z is 9. They didn't give me any angles, and they're asking for angle z. So now I'm going to use one of my angle formulas. So let's just look at this first one. If I want z, I'm going to change all my a's into z's. So that would be cosine of z equals, and if I change a into z, so it'll be negative z squared. And then my other letters are x and y, so I'm going to change all my b's and c's into x's and y's. So that's the formula I'm going to use to find angle z. So fill in the information. Fill in your values, and we get 3 squared plus 7 squared minus 9 squared over 2 times 3 times 7. When you type this in, you want to put parentheses around the whole numerator, parentheses around the whole denominator, so that the calculator knows what to divide. So I'm going to have parentheses 3 squared plus 7 squared minus 9 squared, close your parentheses, divided by parentheses 2 times 3 times 7, close the parentheses, hit equals, and you get negative 0.55, negative 0.5, let's say 5476. Now, does that seem like a logical angle measurement? You should think to yourself, no, that's really too small. That's because we still have to do the inverse cosine to the other side in order to find z. And when you take the inverse of that, second cosine of the answer we got is 123.2. Now that seems like an angle measurement now. Let's say that I wanted minutes. You would take the, so that'd be 123 degrees. So take off the 123 and take the decimal part times 60, and we get 12 minutes if they asked for minutes. Here we don't know what they really want. Okay, last one, example 4. You have a triangle XYZ. Okay, let's label it. X is 3, side Y is 7, side Z is 11. Find angle Z. It'll be the same formula that we just used. Plug in your information. Put parentheses around the numerator and around the denominator. Let's type it in. Parentheses 3 squared plus 7 squared minus 11 squared, close parentheses, divided by, open parentheses, 2 times 3 times 7, close the parentheses, hit equals, we get negative 1.5. We're going to then take the inverse because that doesn't make sense. And it says domain error. So there is an error, let's spell that right, which means there is no such triangle. So the reason it didn't work mathematically is because cosine has a range of -1 to 1. Negative 1.5 is way too small. There is no angle that will give you that cosine. So that's why there's an error. But why is there no such triangle? It's just because the way these side measurements are, there's no way for it to be 3, 7, and 11. You're going to end up with something like this, where the sides just don't match up to make a perfect triangle. Something's going to be wrong. So it's just no such triangle if you ever get that error message.